Apply. Imagine looking up at the night sky and realizing those tiny dots of light are not just stars, but ancient messages, whispers from billions of years ago. Tonight, apply. We step into a journey where time and distance blur, where telescopes become time machines, and where the very edge of human knowledge is pushed to its breaking point. Apply. What lies beyond the stars we see? How far can our eyes, our machines, our imagination really reach? We're not talking about the end of the universe. No. Apply. This is about the astonishing horizon of human discovery. From the birth of galaxies to the invisible echoes of the Big Bang, apply. This story is not just about science, it's about us, our hunger to know, to see, to push further than ever before. Apply. So let's unlock the secrets together and take one step closer to the unimaginable. When we talk about how far humanity can really see into the universe, apply. The number is almost too staggering to believe. 46 billion light years in every single direction. Imagine that for a moment. A light year is already so massive. Apply. The distance light travels in a year, about 6 trillion miles. Now multiply that by 46 billion. That is the size of the observable universe, the part we can detect. Apply. The cosmic bubble that surrounds us. And yet, here's the twist: what we can see is only a fraction of the truth. The real universe may be infinitely larger. Apply. Stretching far beyond the boundaries of even our boldest imagination. Why 46 billion and not just 13.8 billion? The age of the universe itself. Apply. This is where the story gets fascinating. Light has only had 13.8 billion years to travel since the Big Bang. But the universe has not been sitting still all this time. Apply. It has been expanding, stretching space itself. That expansion means the galaxies we now observe as they were billions of years ago have, in fact, apply, drifted far away, so far that the distance we measure is not the light's journey time, but the ever-growing space between us and them. In other words, when we look out into the cosmos, apply, we are not only peering back in time, we are also witnessing the expansion of everything itself. Picture this: the night sky you see above is filled with ancient light. Apply. Every star you gaze upon is a messenger from the past. Some of those tiny glimmers traveled thousands, even millions of years before finally reaching your eyes tonight. Apply. But when we use our most powerful instruments, the Hubble Space Telescope and now the James Webb, we push that window back even further. Apply. Catching light that has been traveling not just for millions of years, but for over 13 billion. That light began its journey when the universe was just a newborn. Apply. When galaxies were first beginning to take shape. So why does this matter? Because the observable universe is like the edge of a spotlight in the darkness. It's not a true border. Apply. Beyond that limit, the universe keeps going. There are galaxies, stars, entire structures we will never see because their light will never reach us. They exist, but they remain hidden. Apply. Forever beyond our cosmic horizon. In a sense, we live inside a bubble of knowledge, and that bubble grows as time passes and light from more distant corners finally arrives. Apply. But at the same time, the expansion of the universe is pushing some galaxies away so fast that their light will never reach us, no matter how long we wait. Apply. The horizon is both a gift and a cage. Scientists call this the observable universe for a reason. It is not the end of existence, only the end of what can be seen. Apply. And that boundary is moving, shifting, reshaping what we believe to be the truth. Right now, our observable universe contains at least 2 trillion galaxies. Apply, each one filled with billions or even trillions of stars. But that's just what fits inside the bubble. Beyond it, who knows? It could be another trillion galaxies. Apply. Or it could be an infinite stretch of space with no boundary at all. Think about what that means for us. Here we are. Apply. One small planet orbiting one ordinary star in one galaxy among trillions. Yet, from this tiny vantage point, we can map out nearly 93 billion light years across. Apply. Humanity has stretched its vision almost to the edge of creation itself. And still we know in our hearts, in our science, in our imagination, apply, that there is more, always more, waiting beyond what we can see. If you want to know how far humanity can really see, you have to go beyond galaxies, beyond stars. Apply. Beyond even the most distant clusters of light, you have to go all the way back to the very first whisper of creation itself. That whisper is still with us. Apply, echoing quietly through the cosmos. It's called the cosmic microwave background, and it is the farthest light humanity has ever detected. Apply. To look at it is to see the oldest story ever written, the afterglow of the Big Bang. 13.8 billion years ago, the universe burst into existence. Apply. But in those first moments, it was not filled with shining stars or graceful galaxies. No, it was a furious sea of energy, dense and hot. Apply. So hot that matter as we know it couldn't even exist. Photons, the particles of light, were trapped in this storm, constantly colliding with electrons and protons. Apply. Unable to travel freely for hundreds of thousands of years, the universe was essentially opaque, a cosmic fog where light had no path to escape, and then everything changed. Apply. About 380,000 years after the Big Bang, the universe cooled just enough for protons and electrons to come together, forming the first atoms of hydrogen. Suddenly, light was freed. Apply. For the very first time, photons could move without being scattered, racing off into the cosmos. Those photons never stopped. They are still traveling today. Apply. Stretched and weakened by the expansion of space, cooled from blinding radiation down to a faint microwave glow. That glow fills every corner of the universe. Apply. A ghostly backdrop that we can detect with sensitive instruments. That is the cosmic microwave background. Imagine it like this. When we measure this faint radiation, apply, we are literally catching the oldest light in existence, light that has been traveling across space for nearly 14 billion years. It is the baby picture of the universe. Apply, a frozen snapshot of what everything looked like when the cosmos was just a tiny fraction of its current age. This isn't just starlight. Apply. This isn't just cosmic trivia, it's the ultimate record, the fingerprint of creation itself. The discovery of this background radiation was almost an accident. In 1965, apply, two radio engineers, Arno Penzias and Robert Wilson, were working with a giant antenna in New Jersey. They were trying to tune it for satellite communications. Apply. But no matter what they did, a mysterious hiss of static filled their detectors. They cleaned the antenna, even removing pigeon droppings, thinking maybe birds were the cause. Apply. But the noise persisted, coming from every direction in the sky. What they stumbled upon was not interference. It was the oldest signal in the universe. Apply. The faint microwave glow from the Big Bang. That discovery would change cosmology forever. Since then, scientists have mapped the cosmic microwave background in extraordinary detail. Apply. Missions like COBDO-VMMEP and most recently the Planck satellite have revealed that this glow is not perfectly uniform. Tiny fluctuations, slight variations in temperature, apply, dot the map of the early universe. And those tiny differences, fractions of a degree, were the seeds of everything. Where the radiation was just a little denser, apply, gravity pulled matter together. Those spots grew into galaxies, stars, and eventually us. In a real sense, apply, the cosmic microwave background is not just a snapshot of the past, it's a blueprint of the future showing where the cosmic web of galaxies would one day form. Apply. When you look at that faint glow, you are seeing a horizon beyond which we can never look. No telescope, no matter how powerful, can peer deeper. Apply, because this is the limit of light itself. Beyond the cosmic microwave background lies a universe still hidden in darkness, the unlit moments before photons were free. Apply. That is the cosmic veil. We cannot see through it. We can only infer what happened from the patterns we find in that ancient glow. And so, apply. The cosmic microwave background stands as a wall of time, the final frontier of light. It is the farthest humanity can see with our eyes, our machines, our science. Apply. Beyond it lies the unknown, but within it lies the greatest story ever told, the moment when darkness broke and the universe first revealed itself to the light. Apply. Every time you look through a telescope, you are not simply looking into space, you are looking into the past. It sounds like science fiction. Apply, but it's a truth so profound that it reshapes the way we understand the universe. Telescopes are more than instruments of glass and metal, they are time machines. With them, apply, we can see not just across distance, but across time itself, witnessing events that happened billions of years ago. Here's why. Light does not travel instantly. Apply. It takes time to move from one place to another. The light from the moon takes just over 1 second to reach us. Sunlight takes 8 minutes. When you see the sun shining in the sky, apply, you are actually looking at how it was 8 minutes ago. That means if the sun were to vanish this very moment, we wouldn't know until 8 minutes later. Apply. Now stretch that idea across the universe, and suddenly every star, every galaxy becomes a window into history. The Andromeda Galaxy, our closest major galactic neighbor, apply, is about 2.5 million light years away. Apply. That means the light we see from Andromeda tonight left its stars 2.5 million years ago, long before humans even walked the Earth. When you stare at Andromeda, apply, you're witnessing a portrait of the cosmos frozen in ancient time, and that's just the beginning. Telescopes like the Hubble Space Telescope changed everything. Launched in 1990, apply, Hubble has captured images of galaxies so far away that their light has taken billions of years to reach us. When we look at them, we are not seeing them as they are today, apply, but as they were when dinosaurs roamed our own planet. In some cases, we are seeing galaxies as they were when they had just formed more than 13 billion years ago. Apply. Only a few 100 million years after the Big Bang, Hubble allowed us to stretch our vision almost to the edge of creation. And now we have gone even further. Apply. The James Webb Space Telescope, launched in 2021, is humanity's most powerful time machine yet. Unlike Hubble, which sees mainly invisible light, Webb peers into the infrared. Apply, detecting the stretched out glow of the earliest galaxies. Its mirrors, coated in gold, will apply, are tuned to catch the faintest whispers of light that have been traveling across the universe since its beginning. Already, Apply. It has revealed galaxies that existed only a couple of 100 million years after the Big Bang, structures so ancient, so far away, apply, that they challenge our very theories of how the cosmos formed. Apply. What makes this so staggering is that we're not only looking back in time, we're watching the story of the universe unfold. We're seeing the first stars ignite, apply, the first galaxies swirl into being, the earliest building blocks of everything we know. Telescopes are not simply tools of observation, they are chronicles of history. Apply, capturing moments that no longer exist, but still live on in the light reaching us today. And it's not just the great space observatories, even the smallest backyard telescope, apply, when aimed at Saturn's rings or Jupiter's moons, is showing you a moment that has already passed. You're always looking into history, no matter how near or far. The deeper you look, apply, the older the story becomes. There's something deeply humbling in this truth. Every beam of starlight that touches your eyes tonight is a message from the past. Apply, traveling across unimaginable distances, surviving cosmic collisions, the bending of gravity, and the relentless expansion of space itself. And when we build bigger, apply, more powerful telescopes, we are not just expanding our field of view, we are stretching our reach into the past, closer and closer to the very dawn of time. Apply. So when we call telescopes time machines, it's not poetry, it's reality. They take us back to moments that no longer exist anywhere else. Apply. They reveal a universe that is both ancient and alive, and with every new glimpse, apply, they remind us of just how small we are and just how far we've come in our quest to see beyond the horizon of time. When we talk about the horizon of discovery, apply, we're not just talking about the edge of space that our telescopes can currently see. We're talking about the edge of human imagination, the limits of our tools, apply, and the barriers that stand between us and the ultimate truth of the cosmos. For centuries, apply, humanity has looked up at the stars and believed we were nearing the limit of what could be known, and yet every time we reached a horizon, we found another waiting beyond it. Apply, that is the story of science, and it is the story of our place in the universe. Think about where we stand today. With our instruments, we can map galaxies billions of light years away. Apply. We can trace the afterglow of the Big Bang itself. We can even detect the bending of light by invisible structures like dark matter. But as far as we've come, apply, there are still mysteries wrapped in layers of darkness. The universe, it turns out, is mostly made of things we cannot see, dark energy and dark matter. Apply, forces and particles that shape everything yet remain hidden from us. That's a horizon of discovery we have not yet crossed. Apply. And then there's the question of the true size of the universe. Right now, we speak of the observable universe, 46 billion light years in every direction. Apply. But that's only the part of the cosmos whose light has reached us. Beyond that boundary lies the unknown. There may be countless more galaxies, perhaps even an infinite expanse. Apply. There could be regions where the laws of physics are not quite the same as here, places forever beyond our reach. The horizon is not just a line in space, it's a limit of possibility. Apply, but every limit we've ever faced has pushed us forward. New technologies are already reshaping this horizon. Apply. The James Webb Space Telescope has begun to reveal galaxies older than we thought possible. In the decades to come, we'll launch even more advanced observatories, apply, capable of peering deeper into the invisible universe, detecting not just light, but the faint ripples of gravitational waves, the tremors of black holes colliding, apply, and perhaps even signs of life on distant worlds. Each of these discoveries will redraw the map of what we know, shifting the horizon further out. Apply, but the horizon of discovery isn't only about how far we can see, it's also about how deeply we can understand. We may one day uncover the true nature of dark matter. Apply. We may finally decipher the force of dark energy that is accelerating the expansion of the cosmos. We may even glimpse clues about what existed before the Big Bang. Apply. If such a question can be answered at all, these are not small mysteries. They're the biggest questions in existence, and they remind us that even at the height of our knowledge, apply, we are still standing at the shoreline of an infinite ocean. Perhaps the most profound part of the horizon of discovery is that it will never end. Apply. Every generation thinks it has reached the final chapter only to discover a new volume waiting to be written. The horizon recedes as we approach it. Apply. And in that endless pursuit lies the beauty of science. We are explorers not of seas or continents, but of time, matter, and existence itself. Apply. And though we may never reach the absolute edge of the universe, the journey toward it is what defines us. So when we ask, apply, how far can humanity really see? The answer is not a number, not a fixed boundary. The answer is that our vision grows with every question, every telescope, every discovery. Apply. The horizon is not an end. It is an invitation, an endless call to keep searching, to keep wondering, to keep reaching into the darkness, knowing that beyond every horizon Apply. There is another waiting, ready to be revealed. And so as we look deeper and deeper into the cosmos, we realize the farther we see, the more endless it becomes. Apply. The universe is not showing us its end, it is showing us infinity.